build. So imagine if we'll start off with a basic inequality. So in terms of solving this inequality, taking away 2x from both sides, of course, greater than 5x plus 1. Taking away 1 from both sides, we're left with minus 4 is greater than 5x, and then minus 4 over 5 is greater than x. Or you can write it as x is less than minus 4 over 5. So that's one way of writing it. For this particular inequality, what we would do is we would say x is an element of, and what we'd say is it's in between two values. So the curved bracket means not including. So when you have this strict inequality, that's what we're going to have. And on the right-hand side, we put the upper bound. And on the left-hand side, we put the lower bound, which in this case would be minus infinity.
Okay.
But I'll show you like a multitude of examples.
At school, they want us to use curly brackets or something.
Sorry?
At school, they want us to use curly brackets.
Oh, really? So there's normally there's round brackets and square brackets, as in the two mean different things. And it's a known thing in maths that the round brackets are when you have strict inequalities, and the square bracketed ones are the ones where it's not strict. Curly brackets typically are for finite sets.
Okay.
So, for example, if you had, I don't know, x is an even number between 1 and 21, let's just say, then you could list the numbers like this, and this is where you'd use curly brackets to list the finite numbers, and that would be the use of the curly brackets typically. So anything that's usually finite or displays a finite number of things, curly brackets are used. But then the round brackets are used for those inequalities typically.
Okay.
Yeah. Like that's definitely mathematically correct. Using curly brackets for inequalities isn't right. If the school does that, just saying.
Okay.
Yeah.
Okay.
But yeah, of course, we can work through some inequality related questions, and then we can incorporate that in our answers.
Yeah. Let's do it.
Cool. All right. So, well, in fact, how about if I give you an inequality to solve, like this one? Sorry, do you know what? I was actually meant to put this sign, so I'll just change that, because otherwise it's just the same as the one before. Yeah, you've got it. And then now just the idea is to put the, what do you call it? The set notation as you were mentioning. So in this case, we'd say x is an element of. So we'd use a square bracket, the minus 9 over 7. And then for minus infinity, we have to use a round bracket, because with infinity, minus infinity, you'll never get a square bracket because nothing equals infinity.
Okay.
So that's one there.
Again, what does a square bracket mean again?
the square bracket means when it does involve. So x can equal -9/7.
Okay.
So because we've got this inequality symbol, which I did change partway through the question, that implies the square bracket.
Okay.
I'll charge this. Okay, I'll give you another inequality to solve on the next page. So I'm just going to charge this as well. Keep in mind that I made the inequality on the right and strict inequality. So when you wrote 2x
Right. So
minus
it's
4
not
is less than 1, I think you changed it.
okay.
So what about the other ones that you put as well?
Mm-hmm. Or I could just say that x is equal to 2. Or no, could be decimal.
Yeah. And so in this case, so this is where the brackets are involved. If it were just x is equal to 2, well, you could just write x equals 2, or you would use x as an element and then curly bracket 2, and then
Okay.
close curly bracket. Because remember, curly brackets are for finite things.
Mm-hmm.
And then these brackets are for when you've got ranges of values.
Mm-hmm.
Okay. Do you know what the graph of sine looks like?
Yeah.
Yeah. Okay.
Mm-hmm.
In that case, then, um, would you give me the values of x for which sine of x is greater than 0? And this is specifically for values of x between minus 360 and 360. So with a question like this, you absolutely want to just draw a graph so that you can visualize it. Give me 1 moment, I'll be back. Yes. So, to lay out the notation for this,
Mhm.
you're going to have two inequalities
Okay.
or two separate bits. Cool. Now, to, yep.
And then would I have to do another one just like this for the other inequality?
You would, yes. And then something goes in between the two. So I'll put the other bracket here so that you can put the other inequality.
Mhm. Would it be union?
Yes, indeed. And then with this, you can surround this with curly brackets if you so wish.
Mhm.
Ooh, that is not a curly bracket. Because the curly bracket now is like talking about these two infinite sets. So the sets themselves are infinite, but the number of sets you have is finite, so you can surround them with curly brackets. If that makes sense. But you don't have to have, you're muted. You don't have to have the curly brackets there though. You could even just leave it without. That's
Okay.
fine. But yeah, that kind of thing is good. Okay. Right, we'll do some quadratics and then I'll try to challenge you.
Okay.
You know when you drew the sine graph, was that from GCSE knowledge?
Yeah.
Just from GCSE knowledge?
Yeah.
That's pretty good.
Okay.
Yeah, the fact that you remember. Okay. Could you solve this inequality on slide 6?
Mhm.
Oh, I think you got it. Hold on. You put x plus 5 times x plus 1. The two numbers have to multiply to give 6 and add to
So
give
x plus 6 minus 1. Okay. No, no. 3 and 2.
Yes.
Yeah. That was a really silly mistake.
That's all good. So yeah, your critical values are at x equals minus 3 and x equals minus 2. Yeah.
And then would I say that?
Yes, union. And then you just put them in set notation. Yeah, that's it.
Okay.
You got it.
Good.
Okay, let's make this just a little bit harder.
Mhm.
Or maybe not a little bit, maybe like a lot harder. So, oh, well, in fact, we'll get to it when we come to it. So this question would have been like a hence solve the inequality. On slide 7.
Mhm.
Mhm.
Would that be the right place to start off?
Yeah, you could do that. Hmm. I'd say that there are a few more points you can take from the previous question that we did
Mhm.
to give even more information about what tan x should be. So just looking back. Yeah, so for the previous one, we had x must be less than -3, x must be greater than -2.
Mm-hmm.
For the quadratic equation, x squared plus 5x plus 6 is greater than 0. This is essentially the same equation, just instead of it being x, it's now tan x. So whatever held true for x in the previous question must hold true for tan x, because it's just been replaced. Does that make sense?
No.
No?
No.
So if you look at the one on slide 6,
Mm-hmm.
it said x squared plus 5x plus 6.
Mm-hmm.
And then this one on slide 7, it's a carbon copy in figurative speech, but the x has been replaced with tan x.
Mm-hmm.
So it's tan x squared plus 5 tan x plus 6, and it's greater than 0.
Mm-hmm.
So keep in mind that in the previous inequality, the solution was x is less than -3 or x is greater than -2. So if that's the case, then in this inequality on slide 7, we can say that tan x is less than -3 union tan x is greater than -2.
Okay.
Right? Because it's the same information. If this were like a part A, part B kind of thing, you could just go straight and say that without going through all the work. Because if the previous one was true for x, then this one must be true for tan, because it's just a replacement. And now we just need to work out what values x could be. Let's put a restriction just to not go overboard. So let's say, again, -360 is less than or equal to x, which is less than or equal to 360. So to work out what this would be, we'd need a tan graph.
Mm-hmm.
Do you remember what a tan graph looks like?
Sort of.
Sort of. I'll help you out with this one. I'll draw it,
Okay.
and then we're going to use the graph to solve the inequality. So that's 0, 90, 270. No, that is a lie. That's 180. That's 270. This is 360. So that's all we need to draw up until. Okay, so this is -90, -180, -270, and then -360. So we specifically have to have that tan x is greater than -2. So let's just say -3 is down here, and -2 is up here,
Mm-hmm.
not drawn to scale. So it would be nice to work out. In fact, if I let you have a go, do you reckon you could try to work out what we might need to do?
Do we need to find x?
Mm-hmm.
So then we do tan inverse.
Indeed.
Mm-hmm.
So inverse tan of what? Which one are you going to go for first?
So what I would say is x is less than tan inverse of -3.
Cool. So we want to be careful with saying less than, more than, but
Mm-hmm.
yeah, that may very well be the case.
Okay.
So if we take inverse tan of -3, so tan -1 of -3, What does that give you? That's a calculator thing.
And then tan inverse of -2 gives us this.
Cool. Oh, does it? It gives you.
That should be minus.
Oh, okay. I was gonna
Yeah.
say. Right. That was surprising. I was gonna be like, what? Okay, so those points are actually here then. So here and here. Cool. So now, in terms of working out, we have to be very careful of what we say now about x. So at this stage, what we'd need to do is say x can be less than minus 70.57.
Mm-hmm.
71.57. But there's also another restriction that we have, if you see on the graph.
The asymptote.
Yes, so it can't equal minus 90.
Mm-hmm.
So it's got to be in between minus 90 and minus 71.5.
Okay.
So that's one inequality. Another is the x must be more than minus 63.44,
Okay.
or minus 63.44 must be less than x, which is less than the 90 because of this asymptote.
Okay.
And then we've also got some other values because we're in between minus 360 and 360. So I'm going to mark them in green. The same scenario happens here because that's also at minus 3.
Mm-hmm.
And also here, that's also at minus 2. Here, this is also minus 3. And here, this is also minus 2.
Okay.
Do you know how, well, do you have an idea of how you might be able to work out those green values?
Would we just take away 90?
Take away 90.
So if we're looking at
Mm.
this value, we take away 90 and we get this.
So we're saying that the distance between each of the blue lines that I've written are 90.
Yes.
Have a look at where it hits the zeros.
Wait, does that... Okay, that hits at 270.
The
So
zero,
there's...
as in where the
That's
graph,
180 and that's at 0, so 180.
yeah, the gaps are 180. So instead of
Okay,
subtracting 90, we'd subtract,
180.
that's it.
Okay. So that would mean the other inequality would be minus 270. So that's an x, which is less than minus... What would that be?
Is it that?
Mm-hmm.
I feel like you might have still taken away minus 90.
Minus 90 again.
I think that's what you,
Minus 251.
yeah. And then there's one more set. So yeah, you've taken away 180 from 63. Yeah.
Mhm. And then where would the next set be on the
Where the
graph?
other green dots are. So you've done it.
Okay, so it's just the positive one now.
Yeah. In fact, there are two
Okay.
more. In
Okay.
fact, no, we've done. No, yeah. There are two more because there's this one and
And
then this
there's
one that I
this one as
didn't
well.
mark. Yes, the ones that I didn't mark.
Okay.
I'm wondering how likely you would get a question like this
Hmm.
because it doesn't go beyond A level, but it's definitely one that requires more thinking.
Hmm.
But if anything, this is just to help you be more careful
Mm.
with drawing graphs and that kind of stuff. Yeah. Yeah. Just checking. Plus 180. Yeah. Plus 182 again. Yeah, that works. And then, yeah, writing it as set notation. Oh, God, that's a bit long. But yes, you'd have your round brackets, union, round brackets, and it'd just be loads of unions. But yeah, that's,
Okay.
I mean, that's pretty much what you need for set notation. There are other funny symbols that we can learn, but none of those will be needed for inequalities. So yeah, I guess there's no need to look at those things just yet.
Okay.
Was there anything else that you wanted to cover? Because I think that's
Could we
like the main aspects covered
could we just go over inequalities
in general.
once more just to make sure that I've got everything down?
Yeah, of course. Well, you've done a quadratic inequality, so that's good. You've done these inequalities, and if you can be careful enough with these inequalities, then I think you'll be careful enough with most inequalities. Um, Let me throw you some discriminant related ones. Okay, let's look at no. Okay, let's look at oh, here we go. Oh, this one's a bit of a nice one. Okay. So slide 8. My first question, just to ask, do you remember what the conditions are for distinct real roots?
So when there are two real roots,
Mm-hmm.
b squared minus 4ac is more than 0.
Yes.
Okay.
Yeah, nice. Yep.
Okay. So it's part I.
Yeah, part two.
So k is more than 0. And
So what's the one thing that you've not done for solving this inequality?
graph.
Yes.
Okay.
Always, always, always. Anything that will make you go, okay, I'm solving an inequality, I'm going to use a graph.
How would I
When
use a graph with this?
Pardon?
How would I use a graph for
So it's
this?
factorized. Imagine if it were x.
Hmm.
X times 4x minus 3. It's been factorized. What would the two critical values be? Or if you were pretending that you were making it equals, what would the solutions be?
Okay, so in that case, I just need to say k is equal to 0 and k is equal to 3 over 4.
So they're your critical values.
Okay. And now I just draw the graph and find the value of k, the set values of k.
That's it. Yes. K is less than 0, K is greater than 3/4.
Mhm.
And then how would you write that in our new fancy set notation that they want so badly? That's it.
Mhm.
Part three. Do you understand this one?
It means that it only has one root.
Yes.
Okay.
How do you know that?
Because if it's a tangent, if the x-axis is a tangent, it means it only touches the graph once,
Yes.
meaning
Tangent.
that there's only one point that touches the x-axis.
Yes. So it's one of those sneaky ways of saying there's one solution.
Mhm.
Yeah, well spotted.
k is equal to 3 over 4.
That's it. There are two values.
0 and 3 over 4.
Yes. And so one exam tip as well, whenever a question says write down, usually there is a way to do this without doing the working.
Mm-hmm.
So, I mean, I don't know if you realized, but when you had your b squared minus 4ac, you got the same result as in part one, except instead of it being saying greater than 0, it just says equals.
Mm-hmm.
So you could have just replaced it with the equals 0 and then worked out the value of k rather than going through the whole process again. But that's fine. As you do, this is one of those things that you'll notice just as you do more questions. Anytime something says state the value of or write down, they're usually going to be like a 1 mark question or maybe 2.
Mm-hmm.
And the point of it is you want to be able to just like spot that there is some relationship.
Mm-hmm.
Cool. There is time for one more. Oh, you wanted the numbers to multiply to give minus 20,
Mm-hmm.
but add to give minus 8, right?
Minus 8, so in that case it would be minus 10 plus 2.
Yeah, yeah. So it should be plus 2 minus 10. Nice. So the coordinates are
Okay, got it.
looks good. Hmm. Oh, you see what you've written. So you've taken the k over to the other side. I see what you're going to do. Yes, should be plus k. That's 64 minus 80.
Yes.
Okay, yeah. Does that say 96?
Yeah.
Where did the 96 come from?
16 times, that is not 6, that's a k.
Yeah.
Okay.
Minus 1. Somehow, I don't think it's going to be minus 1.
Mm-hmm.
I'll explain my reasoning. So my reasoning is because I found a different way to do this question, but we can still stick at it with your way because I just want to find where the mistake was made. Um, Given that you drew the graph and that they've said this equation equals k,
Mm-hmm.
what I then spotted was, oh, k is basically just this line down here that I've drawn in green, where it touches it once, because one solution means only touching once. And I know that this point is the y-intercept, and based on the graph that we've drawn, the y-intercept is minus 5,
Mm-hmm.
which means that this k value down here has got to be lower than minus 5.
Okay.
So I already know that it can't be minus 1. I'm just trying to think where. So b squared minus, so 64 minus, your c value wasn't 5 plus k, your c value was minus bracket 5 plus k.
Okay.
Does that make sense?
Yeah.
Yeah. So I'll rub it out for you. I'll change the c, well, I'll rub out the c value bit so you can look up it as well.
Mhm.
Yes, nice. -9. Because I did it using a different way,
Hmm.
and it worked out to be -9.
Hmm.
Yes. So I thought about it as given that it touches once, it's touching at the minimum point,
Hmm.
and you can get that either by completing the square or recognizing that the minimum point is symmetrical. It's halfway between the two x coordinates that you got.
Hmm.
Um, halfway between the two x coordinates. So halfway between -1/2 and 5/2 is 1, and substitute 1 into the equation and you get out -9. But that's one way in which it can be done. This way works well because you've used the whole discriminant factor, and yeah.
Okay.
So good stuff.
Mhm.
Yeah, you've done well.